Okay, let's look at Chapter 1, Section 2. We're going to measuring and constructing segments. Construction we will do hopefully when you get to come back and see me, because that is a hands-on rulers, protractors, compasses. So we will do everything but those. We will skip those sections. That's the fun part, is getting to draw and use the stuff at the geometry tools in class. Alright, so our academic standards on what we're doing is, again, 1.1, understand the use of undefined terms, definitions, postulates, and theorems, and logical arguments and proofs. We're going to add two-dimensional, that's the 2D, is use coordinate geometry to represent and analyze line segments and polygons, including determining lengths, midpoints, and slopes of line segments. Slopes of lines should sound familiar. You did those in Algebra 1. We found slopes. You use those to draw the lines. We use those to prove, back to this proof, logical proofs, that the lines are really parallel. You use slope, you use the slope set if the slopes are the same in geometry, in algebra, the lines are parallel. We prove it. Geometry, it's about why and proving everything. What we're going to do today is, when we're done, you should be able to use the ruler postulate, compare segments for congruence, use the segment addition postulate. Let's see if there's anything else below there. Nope. That is what we should be able to do at the end of the day. Vocabulary. Vocabulary. A postulate or axiom, depends on what book you use and who the teacher is. They'll use either word. A rule that is accepted without proof. It's a rule that's accepted without proof. Who named the days of the week, and why do we call the first day that we go to school Monday? I don't know, but it's accepted. That's what we do. That's a postulate. A coordinate is a real number that corresponds to a point on either a number line or a coordinate graph. We assign numbers. We say, okay, this is a 1, this is a 2, this is a 3. When you graph them, the first one is 1, second one's 2. That's a postulate. We accept that. We prove that. We go with it. Distance is how far it is between 2 points. Distance is exactly what it sounds like. How far is it from point A to point B? From school to your house? From Walmart to McDonald's? That's distance. How far is distance? Between. When 3 points are collinear, remember, look at that word collinear, and we know that collinear has the word line in it, so when they're on the same line, you can say that one point is between the other, like we talked about in the last lesson. See the example. Alright, so here's our example. Here's what we have. We have a line with points A, B, C on them. B is between A and C. Okay? B is between A and C. Here, I look at this line. I have my line DF. E is not on that line. E is not on that line. It's not here like B is over here. So point E is not between. Yeah, Miss Brooks, if you draw the lines up, it looks like it's between them. Is it on the line? Remember, the points have to be collinear. They have to be on the same line to say they're between. Alright, so postulate 1.1, do not learn the postulate numbers. Know what it says. The ruler postulate. The points on a line can be matched 1 to 1 with real numbers. The real number that corresponds to a point is the coordinate of the point. So when we have this, if I put a ruler here, I can say number 1 is here and letter B is here. Right now I don't know what they are, so that's x1 and x2. The distance, how far apart they are, is written as the absolute value. Remember that from elementary school? Middle school last year? Absolute value is just how far two numbers are. There's no negative to it. Distance is never, never, never negative. The value. So if I'm looking at this in here and I subtract the 2, I have x2 minus x1 and take the absolute value. That's how far they are. Would it make a difference if they said the absolute value of x1 minus x2? Would those two be equal? Yes, they are. Because again, absolute value is just how far two things are. Doesn't matter if I go from the school to Walmart. It's the same distance as it is from Walmart to the school. So it does not matter this order here. Just subtract and take the absolute value, okay? Because absolute value is positive, as everyone wants to say. All right, so congruent segments. Congruent is a stronger way of saying equal, okay? So line segments that have the same length, they're equal if they have the same length, are called congruent segments. That's a geometric term. It means they're equal. You can say the length of a line segment AB is equal to the length of line segment CD. Or you can say line segment AB is congruent to line segment CD. It's just a geometric way of saying they're equal. You need to understand that that's all it's saying, because when you read stuff, it says what's congruent, what's congruent. You need to know they're saying what's equal. That's all you're looking for. The symbol, an equal sign with a little wiggle on top. This means congruent. This symbol means congruent. This is just equal, okay? It's a difference in geometric and algebraic, okay? Geometric wants stronger proof. Algebraic says, we're equal, we're good. All right? So the lengths are equal. They're equal to. Segments are congruent, geometric. This symbol means congruent to. When you look at the book, any book, you will see these little marks right here on the segment. The ones that have the same number of marks are the ones that are congruent. They're equal. All right? So don't worry about what all that means. You just need to know this means that AB is equal to CD. Geometric, it's congruent. Compare segments for congruence. Back to algebra. Let's talk about some algebra and elementary and middle school stuff. Let's plot some points. Let me move that around. There we go. Let's plot some points because we do a lot of that. So if you're still confused on how to plot points, you need to go find a YouTube video, okay? So let's look at our ordered pairs real quick. I'll do this for you. In our ordered pairs, alphabetical order, X comes before Y. X means left or right. Right if it's positive, left if it's negative. Y is up and down. You go up if it's positive, you go down if it's negative. If you give me a point that's in the wrong place, I'm just going to mark it wrong, and I will say regraph your points. X and Y, left and right, up or down. So let's look at our points. J is negative 3, 4. That means I go to the left 3 and up 4. So left 3 and up 4. Label it. That's my J. K is 2, 4. So I go to the right 2 and up 4. So right 2, up 4. That's K. L is 1, 3. That means I go to the right 1 and up 3. So right 1, up 3. There's my L. M is 1, negative 2. So I go to the right 1 and down 2. There's my M. Just connect your first 2 and your second 2. The fact that these are on a straight line means one number is going to be the same. Subtract the number that's not the same, and we're good. So what we do is JK, that's why I connected them, and LM. Are they congruent? We can't just say yes or no, we got to show why. So I look at this, when I look at this right here, which coordinate is the same, the X's or the Y's? The Y's are the same. So all I need to do is subtract the X's. What is the absolute value of negative 3 minus 2? If you're having an issue with signed numbers, you need to go find a YouTube video. Working with signed numbers is a foundation. Every math class that you'll take from now on will not expect you to know how to do this. Okay, so let's go YouTube video and make YouTube your best friend. So negative 3 minus 2 is a negative 5. The absolute value of negative 5 is 5. That is JK. All right, let's look at LM. LM, I'm going to change the color here. LM, what is the same? Which coordinate? The X or the Y? If you look at it, your x's are the same here, so all I need to do is subtract my y's. So 3 minus that negative 2. Goes back to working with sign numbers. 3 minus the negatives, 3 plus 2. So 3 plus 2 is 5. The absolute value of 5 is 5. So, is J, K, and LM congruent? Are these numbers the same? That's all it's asking you. Determine if they're congruent. Yes, they are. And you showed it algebraically. All right. The segment addition postulate says, if B is between A and C, you can draw a picture, then AB plus BC, this part plus this part is equal to the whole thing. The two parts add to equal the whole thing. So if AB plus BC is equal to AC, then B is here. This is just writing this first and then that. Again, conditional statements, we will be talking about those. All right, so we're going to use that to find DF. Well, let's look. DF is from here to here. All right, so looking at the last page, it said that if E is between D and F, which it is, I can have DE plus EF equal to DF. And I want to find DF. That's what it says right here. So DE is 23. EF is 35. And I can add those to tell me what DF is. 23 and 35 is 58. Inches, feet, miles, whatever the unit is. I don't know. It doesn't have one marked. So it's just 58. And that's good. All right, let's change my color. Let's look at blue. I want to find GH now. GH is just this part right here. Again, we can start with our segment addition. G is between, so FG plus GH is equal to FH. Substitute and replace what I know, so FG is 21, GH is I don't know, FH is 36. So one-step equation, not a whole lot to do here. Subtract your 21 from 36, and we're good to go. So 21, x is equal to 15. And if you had already been sitting there yelling at the computer saying, Miss Brooks says subtract it, yes, that's all you've got to do. But this is the work I want to see. The answer is awesome, but you need to know how we get to it, not just what the answer is. And that's all there is, so there will be work in your book. Talk to you later.